let's say we have vector d. Vector d is equal to 12 meters at an angle of 12 meters at an angle of 23 degrees north of east. In other words, it looks like this. Our vector d is at an angle of theta. We're going to figure out d in the x direction and d in the y direction. So instead of, notice, we started with vectors a and b when we figure out the resultant vector. Now we have the resultant vector, and we're going to figure out the pieces that add up to that. So if you look at this, we have a triangle. We know one side of the triangle, the hypotenuse, and we know the angle theta. So we can say sine of our angle theta equals the opposite over the hypotenuse. Opposite is d in the y direction divided by the hypotenuse, which is just d. In other words, d in the y direction equals d times the sine of theta, just multiplying both sides by d. So we get d in the y direction then equals 12 times the sine of 23 degrees. What do we get? 12 times the sine of 23 degrees, please. 4.68877, so we'll do 4.689 is plenty. So with sig figs, 4.7 meters. Okay. We can do the same thing with cosine. Cosine of theta equals adjacent over hypotenuse. Adjacent to our theta is d in the x direction divided by the hypotenuse, which is d. So we get that d in the x direction equals d times a cosine of theta. So d in the x direction equals d, which is 12, times the cosine of our angle, which is 23 degrees. We get please. Times the cosine of 23. 11.46? 0.46, thank you. In other words, approximately 11 meters. Now, what we have figured out is d in the y direction. Notice that this is a vector. The positive here and the y here means that it's in the positive direction, and we have the magnitude, 4.7 meters. We also have d sub x, which means that vector d in the x direction, along with the positive, we know its direction is in the positive x direction, and it has a magnitude of 11 meters. Now, what we have just figured out are called the components of vector d. So if you take d in the x direction and you add it to d in the y direction, you get the vector d. D sub x and d sub y are the components of vector d. When you add them up, they add up to the resultant vector d. That makes them the components of vector d. They make up vector d. Now, notice how we just did the reverse of what we did before, right? Rather than we started with the components before, we added them up to get the hypotenuse. Here we start with the hypotenuse and the angle to get the components. Anytime you are given a vector, when you start a problem, and you have a vector that is neither directly in the x direction or in the y direction, you should always break the vectors into their components. If it's directly in the x or the y direction, you don't need to break it into its components, but any vector that's neither directly in the x direction or in the y direction, you need to break it into its components. Now, I will say that right now this is 100% true. There will be some cases where this is not true, and I will specifically identify with them when they occur, but at this point, it is 100% true that you should always break a vector into its components whenever you start a problem.